Alrighty. All right, so we're going to go ahead and continue on with our review of topic 7. So let's go ahead and skip down past the problems we've already done. All right, so it says write the product in standard form. This really isn't hard, other than we have to deal with some decimals here, but we got calculators for that, right? Okay, so remember, these are like the special forms for multiplying. So you notice that these two guys are the same, right? And then these two guys are the same. The only difference is we've got a different sign in between them, right? So what that does for us is that will drop out the middle term. Because if you actually FOIL this out, you'll get one positive 3x and one negative 3x. Okay? And those two will drop out. So when you see this setup here, you know you just need to square the first guy. And if you're not sure what 1.5 times 1.5 is, we'll just break out the calculator, right? Everyone must be having Wi-Fi problems because it's just you and Chloe today, Taylor. So we do 1.5, at least so far, times 1.5. So that's 2.25, okay? So this will be 2.25. X times x is x squared. Plus and minus is minus. 2 times 2 is 4. And that's it. It's really that easy. All right, so the next guy is something squared. So that means we won't have a positive and a negative. We'll have a negative that when you FOIL it out, like there'll be an AB term twice. There'll be two AB terms. There'll be an A squared and there'll be a B squared. So again, we can follow the pattern for these guys. And once you know the pattern, it makes it a little easier because we don't have to sit there and FOIL this whole thing out, right? So again, same deal. We're going to square this guy. So 3 times 3 is 9. A times A is A squared, right? And then we do the same thing with this guy. Now remember, even though it's negative, it's going to be minus 5 times minus 5. So this is plus 25. So this last guy is always positive. And then B times B is B squared. All right, so that's those two guys. All right, we got some people rolling in now. Nice to see you, Gabe. All right, so for the middle, like I said, it's going to happen twice. And what we end up doing is you're going to just multiply 3 times minus 5. So that's going to be minus 15. And then A times B is just A times B. So we said that's going to happen twice. Because you go this direction, it's going to happen. You go this direction, it's going to happen again. So you can either say I'm going to multiply by 2, or I'm just going to write minus 15AB and add them together. Either way works. So this time we'll multiply, just for the heck of it, right? So negative 15 times 2 is negative 30 AB. And I'm just doing this to show you. After a while, you just get used to it, and you say, okay, so this will be minus 30 AB. And that's our guy. So when you have something squared, you will get a middle term. And when you have stuff that looks the same, but one's plus and one's minus, you will not get a middle term. So we didn't get an x over here. Okay? All right. Questions? Good? Okay. No questions from Chloe. Let's go ahead and move on. So yeah, just remember this guy here, no middle term. This guy here will have a middle term. And again, that's kind of a big deal when you start doing like ACT, SAT, because they'll give you something like this, and they'll give you a bunch of answers. Some will have middle terms, some won't. Some will have positives where there should be negatives, stuff like that. Most of the time, you don't have to actually do the problem to figure out the answer, which is pretty sweet. All right, so let's continue on. Something a little visual here. So this says, find a value for m to make this statement true. Okay, so over here, we've got the same stuff, right? We've got a 5x, we've got an 8, but one's plus and one's minus. So notice there's no middle term to this guy. So 8 times 8 gave us or 8 times negative 8 technically gave us the negative 64. So what should m be in this case? What should that m value be? So kind of follow the pattern. No, not quite. So we figured out the minus 64 by saying 8 times negative 8. So what would happen if we multiplied these two guys together? 5x and 5x, what will we get? Yeah, you'd get the x squared, right? But then 5 times 5 is 25. So in this case, m would have to be 25. See how that works? So since the two are equal, we figured out that if we did positive 8 and negative 8, that gave me minus 64. And if I do 5x and 5x, I get 25x squared. This just has the x squared, so that means the m has to be 25. Make sense? All right, so the next one deals a little more with geometry as opposed to algebra. Okay. So it says, write polynomials in standard form to represent the surface area and volume of the cube. All right, so let's talk surface area. Surface area is how much area each side of the box makes added together. So you need to consider surface area when you're like wrapping a birthday present or a Christmas present or something like that. Okay. So let's just talk about this. So this is obviously a cube. The nice part about a cube is all the sides are the same, right? Okay. So if this side is 5x minus 2, that makes this side 5x minus 2. Okay? So area is length times width, right? So then this would be 5x minus 2 times 5x minus 2 is 5x minus 2 squared, right? Okay, so here's how we can use our pattern, right? So again, we take the first guy and square him. So we square this guy. 5 times 5 is 25. And x times x is x squared. Okay? All right, so then we have minus 2 times minus 2. We square that. That's always going to give us a plus, so it's plus 4. Okay? Then we multiply these two guys together. So 5x minus 2 is 10x. Now remember, that's going to happen twice. It's going to happen going this way. It's also going to happen going this way, right? So minus 10 and minus 10 is going to be minus 20, and then x. Okay? All right, so that's just one side, right? So how many sides are there to an actual box? If you can look at this, how many sides is there actually to a box? Think about it. Yeah, there's 6, right? So here's the 3 up front we can see, and then there's 3 in the back that we can't see.
money, but I didn't want to bother. I haven't emailed her back.
All right, so if one side equals this is one side, right? And we've got 6 sides altogether, right?
Oh, okay.
That means we'll just multiply everybody by, let's see if I can squeeze it in here, 6. All right, so they want the polynomial in standard form, so that means we got to multiply this guy out. Not really a big deal. So we have 6 times 25. So if you have 6 quarters, that's $1.50. So that makes this 150x squared. Then we've got 6 times minus 20, that's minus 120x. And then we've got 6 times 4 is 24. Okay? So this is your surface area.
Okay, good, because if he's taking the EOC and hasn't had first semester, I mean, I'm doing a review, but still.
Okay.
That's a thing there. That's a state test.
So how do we figure out volume? So when we say surface area, this is whatever we got, inches, meters, whatever, squared. So this is square feet, we'll say. Okay. All right, so how about volume? So surface area is 2 dimensions, right? The length times the width. And then we just had a bunch of those that we added together, as we saw, which turned out to be multiplication, actually. Okay. So how many dimensions is a volume? So area is 2 dimensions. How many dimensions is a volume?
Like for a whole 5 minutes, I don't know how long, and it woke me up, and then I couldn't move my arms. I couldn't.
Not 4 dimensions, no. So with the area, we had a length times a width, and we get the same thing here. We got the length, which I mean I know they're the same. So we got the length times the width, right? So here's our length. Here's our width. What's this guy? What do we call that guy? Length times width times what?
But I felt like crap yesterday morning, so I'm like, well, I'm just not going anywhere. So, and I forgot to put my message to everyone. But so I just worked at home.
So this is the height. And since it's a cube, the height is going to be the same as the other 2 guys, right? So he's going to be 5x minus 2. So we have length times width times height. That's 3 dimensions, right? So the world is 3-dimensional. The flat screen on your TV is 2-dimensional. And a distance, like from here to Orlando, is 1 dimension. That's just, a certain number of miles or feet or whatever. Okay? So that's what we got going on there. All right, so then to figure out the volume, what we need to do is we need to do 5 and x, and then minus 2, and then since they're all the same, we just raise it to the 3rd power. I don't know why at the top of the screen the pen never wants to work. Okay, well the good news is we already squared it. That's this guy, right? So we already squared it. So we just have to multiply it by 5x minus 2 one more time. So we'll go 5x minus 2, right? And then we're going to have 25x squared minus 20x plus 4. Okay? All right. So you can use the box method, or the table as they call it, or we can just do some mega distributive properties. So again, we have 2 terms in the first guy, first set of parentheses, 3 terms in the second guy. That means we're going to get 6 terms total after we've done multiplying everybody out. And then what typically happens is we'll have a couple things we can combine, and we'll usually end up with like 4 terms. That's typically what's going to go on. So let's go ahead and print this guy out. All right, so we'll start with the 5x. So we do 5 times 25, so 5 quarters is $1.25. So that's 125. X to the first and x to the second is x to the third. Cool. Moving along. Next guy, we've got 5 times negative 20, that's minus 100. X times x is x squared. And then finally we do 5x times a 4, so 5 times 4 is 20. And then just bring the x along. Cool. All right, so let's switch to the minus 2. And we'll switch colors as well. All right. So we do minus 2 times 25, so that's negative 50 x squared. So if we bump this over a little bit, look at this. We can line these guys up. So I got negative 50 x squared. Cool. So then we do negative 2 times negative 20. 2 negatives gives you a positive, right? And then 2 times 20, two $20 bills is 40 bucks, right? You probably notice I talk about food and money a lot because everybody seems to like both. All right, so then we just do the minus 2 times the positive 4. That's going to give us a negative 8. So we do have 6 terms here, right? So that way we know we've multiplied everybody together, right? So the last part was combined like terms, and you notice by offsetting that, I set them up as like terms all in columns, right? So that means we just go ahead and add them up. So this guy here, there's nothing to add to, so you just bring him down. So he's 125 x to the third. And these guys here, I got minus 100 and minus 50 more. That's minus 150 x squared. Then I got 20 and 40 is 60. 3 crisp $20 bills, right? And then finally the minus 8, there's nobody to add him to, so you just bring him down. And that's your answer. Okay, so this one is the volume. Now notice in the volume, you have an x to the third, right? And that's because there's 3 dimensions to volume. And then over here you have an x squared because there's only 2 dimensions to an area. So 2 dimensions is area, 3 dimensions is volume. Okay? Yeah, there's a little crunching going on there. Fortunately for us, since we already did this part in the first part of the answer, we could use it over here, and we didn't have to redo it. So that's a good thing. Questions on that? Yeah, this chapter, it's not so much that it's difficult stuff, but it is a lot of multiplying and just number crunching and stuff like that, which isn't necessarily hard, but it does tend to take a while. Okay. All right, let's move on. So this says, what is the greatest common factor? That's what GCF stands for, greatest common factor. So again, all we're looking for in each of these is we're looking for the biggest number that will divide evenly into all the numbers given. And then we also want to look at, with the variables, you can always bring out the smallest exponent of any variable as long as there is that variable in each term. Okay, so let's kind of apply this here. So let's look at this, 6 and 21. What's the biggest number that'll divide both into 6 and both into 21? Yeah, first thing you always want to look at is you say, well, can I just take 6 and divide it into 21? In this case, that didn't happen, but sometimes it will. And then you just know that it's 6. So 6 didn't work, so it's like, okay, well, he's an even number, so we could use 2, but he's an odd number, so no. So that's why we switched to 3, and you were correct about that. So then the number part of this is just going to be 3. Okay. Then we have an x squared and an x to the first. So we can always bring out the smallest exponent, which is the x to the first, or just x. So our greatest common factor of these two guys is 3x. So if you take 3x and divide it into 6x squared, it'll go in there evenly. And if you take 21x and divide it by 3x, it'll also Oh, and they're evenly with no remainder. Cool? All right, so number 30. We don't have any numbers to deal with. That's a good thing, right? So this one here, we just need the smallest power for B and C. So what's our answer going to be? There's no numbers, so it has to be letters, right? So we got a B to the first and a B to the third, so we need the smaller exponent. Then we have a C to the second and a C to the first. Again, we need the smallest exponent. So what's our greatest common factor here? Does that stand for something? Yeah, BC. I thought that was some new acronym I didn't know. So we bring out the smallest one is B to the first. We bring out the smallest C, which is C to the first. Phone, gotcha. Yeah. Understood. All right, so how about the next guy? So we need a number that goes into 14, into 21, into 84. So what do we think that might be? I don't think 3 goes into 14, does it? So we can't do 2, right? And I don't think 3 works. Here, I don't know if I've told you this one. Here's a good way to tell if 3 divides into something. Add the individual digits together. So I got 14. That's 1 and 4. That's 5. Can I divide 3 by 5 with no remainder? Right. So the moral of the story is this. If the numbers add up, like let's do the 8 and the 4. So 8 and 4 is 12. Can I divide 12 by 3? Yeah, 12. You can divide 12 by 3, sure. So the point of the story is if I can divide 12 by 3, that means I can divide 84 by 3. And it doesn't matter how big the numbers. I mean, it can be 10 digits long. But if you add up all of the terms, all the individual digits, and see if that number can be divided by 3, then that means the big number can be divided by 3 as well. Okay, so 3 will divide into 84. It'll divide into 21, but not 14. So we can't do 3. If you can't do 2, you can't do 4, right? If they don't end in 0 and 5, you can't do 5, right? And if you can't do 2, you can't do 3, right? 2 times 3 is 6, so we can't do 6. Okay? So next up is 7. Does 7 work? Take a second, maybe consult your calculator. See if 7 works for us here. Booyah! So that means our number guy is going to be 7. Like I said, normally this is the hardest part of these, is just trying to figure out the number part. All right, so now we need the smallest exponent. Here's an x squared, here's an x to the third, here's an x. So our smallest guy is just the x, all right? All right, so let's look at the y's. All right, so for y, we got a y squared, y to the fifth, and y to the third. So what's our smallest power for y? Yeah. So then the y part of this will be y to the second power. That's the smallest power. And that's your guy. So again, as you saw, the hardest part was figuring out the 7. All right, so the next one, we've got an a squared, and then we don't have any more a's. So that means we can't factor out any a's because the smallest exponent on an a would be a to the 0. That doesn't help because that's just 1, right? So since this guy has an a squared in it, or an a term in it, my cursor, there he is. This guy has an a squared in it. This guy doesn't have any a's. That means we can't factor out an a. So we have to strictly deal with the numbers. So what's the biggest number that'll divide into both these guys? Six. Beautiful. So yeah, 6 goes into 24, 6 goes into 18. So your greatest common factor in this guy is just 6. And that's it. Questions? So again, the hardest part's figuring out the numbers. After that, you just take the smallest exponent of each variable, counting that there's a variable in every term. So in 32, there was not a variable in every term, so we couldn't do anything with the variables. All right, cool. All right, so again, same thing. We're going to factor out the greatest common factor. The only difference here is they want to know what's left over. Okay, so the last one we didn't have to do that, and this one we will. But that's easy because then all you do is you divide each term by the greatest common factor, and that'll tell you the stuff that's left in the parentheses. All right, so how about this guy? What's the biggest number we can take out of here? Can't be 2 because 15 is even. What about 3? Does 3 work? Yeah, we can do 3, right? So we'll factor out a 3. All right, so then we've got x to the third and x. So we can bring out the smallest guy. So we'll just bring out the x, right? The variables are actually the easy part of this again. So now we need to figure out what 2 terms go in here. So then what we do is we're just going to take 15x to the third and we're going to divide it by 3x. Okay. So 15 divided by 3 is just 5. And we have x to the third divided by x to the first. So how many x's are we going to have left? I got 3 x's on top, 1 x on the bottom. How many is going to still be there? I think it's more than 1. Think of it this way. X to the third is x times x times x. Okay? I can get this thing actually right. There we go. And then on the bottom, we've got just 1x. So remember, anything over itself is just 1. So that means we can cancel out these 2 here. How many x's do I have left? Zero? I see an x there and I see an x there. How many x's do I have left? You're thinking about this too hard. How many x's do I see? Yeah, it's just 2, right? Okay. Another way you can think about this is if I'm dividing by x, I just drop the power here by 1. So instead of x to the third, I've got x to the second. So we do the same thing here. We do 3x. We're going to divide minus 42x by 3x. So minus 42 divided by 3, that's not one that most of us know. So we can always use our calculators, and we say got minus 42, and we divide that by 3. That's minus 14. Cool. And we have x on top, x on the bottom. We know what that means. They cancel, right? So that's your guy. So the second term is just going to be minus 14. And then the moral of the story is if you multiply them back together, this will give me 15. X to the first and x to the second is x to the third. Okay. Then here I've got 3x times minus 14. So 3 times minus 14 is minus 42 times x. There's your minus 42x. You get your original answer back. Good way to check if you did it right, if you're concerned that you didn't do it right. Questions? All right, so how about this guy? What's the biggest number that divides into 6, 42, and 18? Yeah. So again, always take the number, the smallest number, and see if the other two can be divided by it. So if I take 42 and divide by 6, I get 7. That works. And if I take 18 and divide by 6, I get 3. Cool. So that means we can drag a 6 out front. And then what's our smallest exponent? Y to the what? Remember, lazy math guys don't write this. This is y to the first. So what can we bring out front as far as the variables? So the smallest exponent is y to the first, right? So you just bring out a y. There we go. All right, so now we're going to figure out the stuff that goes inside. So again, we'll do 6y. So we're going to take 6y to the fifth and divide by 6y. 6 divided by 6 is just 1, right? And we have y to the fifth and y to the first, so that means just drop your power by 1. So this guy becomes y to the fourth. Cool. Next guy, same thing. So we got minus 42 divided by 6 is going to be minus 7. And then again, we're dividing by y, so that means drop your power from y to the third to y to the second, right? Then we do our last guy here. We divide him by 6y. So 18 divided by 6 is just 3. And y divided by y, anything over itself is just 1. So y divided by y is just 1. So that last term is just 3. And that's your guy. Okay. Let's do 35 and we'll call it. So what's the biggest number that divides into 12, 18, and 36? Yeah, it is 6. We could try 12, but 12 doesn't work with 18, so we backed it off to 6. Good. So we got 6. And we look at our exponents. We've got x to the or a to the third, a to the second, and a to the first, which means the small guy, a to the first, comes out. Good. So now we just do the same thing. We say we're going to divide everybody by 6a. So we got 12 divided by 6 is going to be 2. Drop the power by 1. So instead of a to the third, a squared. Right? Do the same thing here. We got 6a. So 18 divided by 6, that's going to be 3. And we're dividing by a, so we're going to drop the power from a to the second to a to the first. Cool. And last guy, we've got minus 36 over 6a, so we know the a's are going to cancel. And then negative 36 divided by 6 is going to be minus 6. And that's your guy. And again, if you multiply this stuff back together, if you distribute this guy back through it, you'll end up with what you started with. All right. All right, so that's probably a good stopping point for today. We'll probably conclude this tomorrow. And I've already got attendance, so you guys are good to go. So I'll shut down the recording. I'll thank you for stopping by, and hopefully we'll see you all tomorrow.